So target 14 notes. Let's go ahead and get started with those. We're still doing the linear programming, just with some word problems. So we're going to be declaring variables, stating our objective function, and then writing out our constraints, which are pretty nicely spelled out for us on this homework. And then graphing those lines, shading, testing the corner points. That's our process for linear programming for target 14. Alright, so the first one, number 1, it says a furniture company makes bookshelves and desks. Each shelf requires 2 hours for carpentry work and 1 hour for painting. Each desk requires 3 hours for carpentry work and 4 hours for painting. The company has a maximum of 60 hours of carpentry work and 40 hours of painting available each week, and they make a profit of $15 per shelf and $40 per desk. How many shelves and how many desks should they make to maximize their profit? Okay, so let's see. Declaring our variables. We're working with shelves and desks here. So X is going to be, I'm going to say number of shelves. And then Y would be number of desks. All right, and then also in the word problem, it doesn't say maximize. I forgot to add that in there. How many desks and shelves should they make to max profit? It will be spelled out in the target checks, quizzes, and tests and stuff. Or just the test, I mean. Alright, so objective function or cost. So like basically if we're maximizing the profit here, if a shelf is $15 and a desk is $40, I'm going to say my objective function is 15x plus 40y. $15 per shelf, $40 per desk. My constraints. Looking at number 3 and 4, I can't have a negative number of desks and a negative number of shelves, so x and y both have to be positive numbers or greater than or equal to 0. My other constraints, one of them has to do with 60 and one of them has to do with 40. Let's work at this 60 one. Let's find 60 in our word problem. Okay, so it says the company has a maximum of 60 hours of carpentry work. So I'm only focusing on carpentry work here. A desk requires 3 hours for carpentry, and then a shelf requires 2 hours for carpentry. So 2 hours of carpentry work per shelf and 3 hours of carpentry work per desk has to be less than or equal to 60. It can't be more than 60 because I only have 60 hours to work with. This company does. So let's see. 2x plus 3y. 2 hours per desk, I'm sorry, per shelf, and 3 hours per desk of carpentry work. Now, the other one having to do with 40, that has to do with painting. So 40 hours total for painting. A shelf requires 1 hour for painting and a desk requires 4 hours for painting. So 1x plus 4y. I'm just going to write x plus 4y. Has to be less than or equal to 40. They only have 40 hours for painting. So I'm going to go ahead and solve here for y, so I can graph these lines. Subtracting over 2x, I'm going to get 3y is less than or equal to negative 2x plus 60. And then I have to do one more thing, divide by 3 here. So my actual function is y is less than or equal to negative 2/3 x. 60 divided by 3 gives me 20. So plus 20. And then my other one, when I subtract over x, I get 4y is less than or equal to negative x plus 40. And then when I go ahead and divide by 4, I get y is less than or equal to negative 1/4 x plus 10. Okay, so I'm going to count by 2's on this graph. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oops. 20. Alright. Now that worked better for me because I have to be starting at positive 20 for my y-intercept on that green one. I'm going to go ahead and graph, first of all, the fact that x and y both have to be positive. So I'm graphing x equals 0 and y equals 0. And basically, everything positive on this graph is fair game. All right, let's do the green one. Y is less than or equal to negative 2/3 x plus 20. So I'm starting at 20, going down 2, right 3, down 2, right 3, down 2, right 3, down 2, right 3, down 2, right 3. Now, the only reason I could go down 2, right 3 and not count like by 5s or by 2s is what I'm doing is because I went the same scale on my x and y axis. So down 2, right 3 is the same as going, you know, down 1 box for 2 and then over 1.5 boxes for 3. It's the same thing. All right, and it says that y is less than that, so I basically need everything under here. And then y is less than or equal to negative 1/4 x plus 10. So I'm starting at 10. I'm going down 1 over 4. And if you notice, that actually overlaps that point right there, which is nice. And then it says y is less than that, so everything under here. I'm going to outline in black my totally shaded region. And then I'm going to test my corner points. One of my corners is 0, 0. One of them is 0, 10. One of them is 30, 0. And then one of them is 24, 4. And it'll be easier to see on your paper than it is on this graph because the markers here are just really thick. So one of the points is 0, 0. Testing that. I'm testing 10, 0. I'm sorry, 0, 10. I'm testing 30, 0. I'm testing 24, 4. Don't forget my objective function was 15x plus 40y. So let's test those. When I plug in 0 for x and y, I just get c equals 0. When I plug in 0 for x and 10 for y, I get c equals 400. 30 for x and 0 for y, I get c equals 450. And then 24 for x and 4 for y, I get c equals 520. So if I'm trying to maximize my profits, that's the way to go. So basically the company needs to make 24 shelves and 4 desks. So the company needs to make 24 shelves and 4 desks. Okay, let's go on to the second one. Piñatas are made to sell at a craft fair. It takes 2 hours to make a mini piñata and 3 hours to make a regular-sized piñata. The owner of the booth will make a profit of $12 for each mini piñata and $24 for each regular-sized piñata. If the craft booth owner has no more than 30 hours available to make piñatas and wants to have at least 12 piñatas to sell, how many of each size should be made to maximize profit? All right, so we're maximizing profit here, which means my objective function is going to have to do with money or cost. Declaring my variables first, we're working with mini piñatas and regular sized piñatas. So I'm going to say that X are my mini piñatas. So number of mini piñatas. And then Y is the number of regular sized piñatas. All right, perfect. And then my objective function, my cost. How much is he going to make total? Let's see. If mini piñatas will profit $12, and then the regular piñatas will make 24 bucks, I can say 12x plus 24y. let's talk about my constraints. Looking at number 3 and 4, very simple. I can't have a negative number of piñatas for mini or regular size, so I'm going to say x and y both have to be greater than or equal to 0. Basically, that means I have to have a positive number, or 0, of both mini and regular sized piñatas. Okay, so let's look at that first constraint. Something has to be greater than or equal to 12. Well, it says that he wants to have at least 12 piñatas to sell. Okay, well, if he wants to have at least 12, that means the number of mini piñatas and the number of regular sized piñatas has to be at least 12. So all this is x plus y is greater than or equal to 12. Because the number of each added together has to be greater than or equal to 12. Alright, and then my other one has to do with the number 30. Let's look for the number 30 up here. Oh, time, no more than 30 hours. Let's see, how long does it take to make a mini piñata? 2 hours and then 3 hours to make a regular sized piñata. So then I can say 2 hours per mini piñata, which means 2 times x, plus 3 hours per every regular sized piñata, or 3 times y, has to be less than or equal to 30, because I only have 30 hours total to make these piñatas. So then my arrows indicate I need to solve for y in order to graph these lines. So I'm going to say that if I subtract over x for the red, I will get y is greater than or equal to negative x plus 12. And then my other one, first I have to subtract 2x, and then I'm going to have to divide by 3. So when I subtract 2x, I get 3y is less than or equal to negative 2x plus 30. Then I have to divide by 3. And I get y is less than or equal to negative 2/3 x plus 10. So here's one of my equations. Here's the other one, and the other one, 3 and 4, just come from being positive. So scrolling up just a little bit, I'm going to go ahead and graph all this. I know that everything has to be positive, so starting off by graphing these 2 lines. Everything positive is fair game, and everything up here. Now, my biggest y value that I'm going to need is 12, so I can actually count by ones here because there's 15 boxes here going up and then going to the side. So I'll graph my red line first. So plus 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is right here. Negative x. So down 1 over 1. Down 1 over 1. Alright, and it says y is greater than that. So shading everything above that line. And then my green one. Negative 2/3 x plus 10 down to right 3, down to right 3. Ooh, it hits that point, that's good. Down to right 3, down to right 3, down to right 3. Alright, so and then it says y is greater than. I'm sorry, y is less than. So I'm shading everything below. And if you can tell, the area of shading between all 4 of those lines is actually right here, this little sliver of graph. Okay, let's find these test points. Well, one of them is right here. It's at 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6. 6, comma 6, that's nice. The other ones are over here at 12, comma 0 and 15, comma 0. So I have 6, comma 6 that I'm testing. I have 12, comma 0 that I'm testing, and then I have 15, comma 0 that I'm testing. Alright, so don't forget my objective function was 12x plus 24y. Let's plug in these points. When I plug in 6 for x and 6 for y, I get c equals 216. When I plug in 12 for x and 0 for y, I get 144. And then when I plug in 15 for x and 0 for y, I get c equals 180. So if I'm trying to maximize profits here, I'm looking for the biggest number. which is 216, which comes from 6 comma 6. So my x value is 6, my y value is 6. Basically, the booth owner needs to make 6 mini piñatas and 6 regular piñatas. In order to maximize profit there. And that's my answer.